Today's objective. I can derive the quadratic formula by completing the square. Let's read it together. 1, 2, 3. I can derive the quadratic formula by completing the square. We already know the process for completing the square. We just did that earlier right now in the warm-up, right? We've been doing it already for the past, whatever, couple of weeks, right? And deriving the quadratic formula. We already know the quadratic formula, but where did it come from? Today we're going to actually make it happen. We're going to create the quadratic formula from scratch, yes. The only thing today is let's call it a culmination of everything that we've done, all the work that we've done, okay? And in algebra, when we derive stuff, many times it involves variables upon variables and not a lot of numbers. For some of you, it's going to be a little bit challenging, but this is the time that I'm going to ask you to trust all the concepts and all the processes that we've learned. Everybody with me? It's kind of like you're going to see something, but then you're thinking, but there's no number there, but there's a variable, but I think it's this step. Trust your step. It will work because all the concepts you already know, all the processes you already know. Does that make sense? It's kind of like, for example, let me give you a quick example. How about Star Wars? Who's seen the movie Star Wars? Okay, there's a movie in there's a part in Star Wars, and let me get some music. No, you don't hate it. So Star Wars, there's this part where Luke Skywalker is in his spaceship, right? And he's about to send a couple of laser missiles to destroy the Death Star. Okay. However, in order to do that, the spaceship is equipped with some goggles that they come down automatically. They go like that in front of them, and on those goggles, you can actually see the 3D image of where the missile needs to go. So, and when he was about to shoot, he pressed the button. Here come the goggles, and all of a sudden he heard the voice, "Luke, use the Force." And then all of a sudden he pressed the button again. He's like, what? He heard the voice of Obi-Wan Kenobi, the guy that was training him. Those of you that are not Star Wars people. And then again, he thought that maybe he imagined the voice, so then he pressed the button. Here comes the command again. Luke, use the Force. Trust your instincts. And then he's all like, oh, that Obi-Wan Kenobi, this one voice. so Obi-Wan Kenobi is a master Jedi that trains Luke Skywalker. So anyways, you need to see the trilogy. But the point here is that he was telling them to trust his instincts, to trust the Force, use the Force. So here I'm going to ask you to use the processes that you already know. Okay? So yes. So here we go. So to get started, you're going to get a piece of paper really quick, like this. Top left corner. I want you to label it this. Landscape, like this. On the top left, you're going to write, derive the quadratic formula. Deriving the quadratic formula. Deriving the quadratic formula. Deriving the quadratic formula. All right, so here it goes. We're going to start from the very beginning, and we're going to actually, at the end, get our quadratic formula, but you're saying, well, we already memorized it. I know, but we're going to actually make it happen from scratch. How do we do that? I'm going to show you right now. Here it goes. First things first. Everybody copy this. After this point, I'm going to ask you to put your pens down. When I ask you to copy, you copy. After that, you put your pens down again. All right? Here it goes. First things first. Copy this down. AX squared plus BX plus C equals Y. AX squared plus BX plus C equals Y. Copy that, please. So, first things first. Whenever we solve a quadratic equation, we said The very first step that we do, we need to substitute 0 for y. I bring everything else down. ax squared plus bx plus c. Are we there so far? Okay, you're still not copying, you're just paying attention. Here it goes. Now I'm going to begin my process for completing the square. Here it goes. Step 1. Is it in standard form? Yes, from greatest to least degree. Okay. Step 2. I'm going to divide by the leading coefficient. What is my coefficient right now? Hold on. We don't have numbers anymore. Now instead of a number, we have a variable. So we're going to divide the whole thing by a. So here we go. What is a divided by a? A divided by a is 1. What is 1 times x squared? X squared. What is b divided by a? B over a, and we have the x in the middle term, plus what is c divided by a? C over a equals 0 divided by a. 0. Copy that, please. So let's see. Step 1, standard form, yes. Step 2, divide by the leading coefficient, yes. Step 3, eliminate the constant. What is my constant? Plus c over a. What is the inverse? Minus c over a minus c over a. I bring everything else down, and I have x squared plus b over a x. These cancel, equals, I'm going to leave a little space here, minus c over a. Copy that, please. Once again, step 1, standard form, yes. Divide by leading coefficient, yes. Eliminate the constant, yes. Step number 4, at this step, I'm going to need your full attention because there's a couple things that we need to see and make sure you follow. Step number 4, we're going to add b over 2 squared. Okay? So, I'm going to add b over 2 squared. Just pay attention on this one. Check this out. Just want to make sure that you're understanding what I'm writing. If we were to look at our original equation, b is located as a coefficient of x. Is that correct? So this would be b. However, we're no longer here. We are here. What is the coefficient of x? B over a. This fraction is actually b. So check this out. So instead of writing just here b, what am I going to write? B over a. B over a. B over a. Copy that, please. Now, before I continue to the next step, I cannot move on until I simplify this. Everybody look up, please. Because according to our definition of rationals, remember at the beginning of the year, we cannot have fractions over fractions. Is that correct? So the definition said we can only have integers on the denominator. So therefore here we have a fraction over another fraction. However, if I was to look here at step 4, what is the 2 doing? Dividing. That means I can rewrite this. Everybody look up. You're just paying attention. B over A divided by 2 squared. Does that look better? Yeah, right? It doesn't look as trippy as this one, right? So whatever I did to one side, I do to the other side. Okay, copy that, please. All right. Now, I'm still not done simplifying this. So before I do the next step, I need your attention. So I'm going to do a quick side note. If I had, everybody look up please, if I had 3/4 divided by 2. To divide these, I need to make this into a fraction. Everybody look up please. And then with that, first fraction stays the same, and we multiply times the reciprocal. Is that correct? Yes. And this becomes 3/8. Are we there? Okay. With that said, let me go back to, this is with numbers. Let me show you now with variables. Check this out. To divide these two, this one becomes a fraction, this one becomes a fraction. This one stays the same. Is that correct? Yes. So this is b/a. However, we change the sign to multiplication and we do the reciprocal. So therefore, this is going to be b/2a to the second power. So I'm going to write this here before you write anything. This is b/a times 1/2 squared, and this becomes b times 1, that's b, 2 times a, that's a to the second power. Copy that, please. Okay, so now, at this point, notice that I started here, but now I simplified it, and now this looks familiar, doesn't it? It's a little bit more simplified. So now I'm going to bring everything else down. I'm going to bring this one all the way down here. So then I have x squared plus b/ax plus, I bring down the equal sign, and I bring down the minus c/a. Are we there so far? Okay, so before you write that, here he goes. I'm going to go to the next step. Step 5. For step 5, I need to factor. Factor. So check this out. This is a perfect square. Why? Because I just completed the square by adding b/2 squared. So check this out. Who remembers this from Saturday? Those of us that did the review. Square root of this, x, square root of this, b/2a. What is the sign for the middle term? It's a plus, so therefore this could be written as squared. And I bring this down. What is b squared? B squared. What is 2a squared? 4a squared. And I bring down the negative c/a. Copy that, please. Oh, yeah. All right. So we checked for standard form, divided by the leading coefficient, eliminated the constant, added b/2a, factored. We're at this point. Before I move on to step 6, I still have something that hasn't been simplified. Let me create some space here. Check this out. There's 2 fractions here that haven't been simplified. Who sees the fractions here? On the right side of the equation. Here's 1 fraction. Everybody look up, please. 1 fraction, 2 fractions. And they're doing what? They're subtracting. In order to add or subtract these fractions, we need a common denominator. Are we there? But this one has 4a squared. This one only has a. What do I need to multiply this side to get 4a squared? Times 4a. And whatever I multiply the denominator, I need to multiply the numerator, 4a. So check this out. Now we can write it as 1 fraction. What would be my denominator? 4a squared. Is that correct? Yes. What do we have in the numerator? b squared minus 4ac. And I bring down the equal sign, and I bring down the parentheses, x plus b/2a squared. Copy that, please. Right here it's 4a times c, therefore it's 4ac. Up here. And our last step to completing the square. We already did all 5 up to factoring. The last step, step number 6, tells us to take the square root. From there, we were to do 2 equations, but since we don't have numbers, we're going to leave it as 1. And we're going to solve for x. 2 EQs and solve for x. So check this out. Square root. Why do I need to take the square root? Because I need to cancel this square, don't I? So therefore, I take the square root of this side, but whatever I do to one side, I do to the other. This cancels this. You're just paying attention. And we're left with x plus b over 2a equals, check this out. Can I take the square root of b squared?
Yes.
Can I take a square root of a negative 4?
Yes, yes.
No.
No, it's an imaginary number. Therefore, where is the negative 4 located? On the numerator. Therefore, I cannot take the square root of the numerator. However, look at the denominator. What is the square root of 4? Square root of a squared. A. So I can do the denominator. So I'm going to leave the numerator the same. That's why I'm going to write plus minus square root. What's left inside? B squared minus 4ac. And what was square root of 4? 2. And what's square root of a squared? A. Copy that, please. Not b squared. The numerator, because it's all together, and the negative 4 is an imaginary, taking the square root. 2 EQs, 2 equations, and solve for x. So for right now, we barely did the square root, and right now we'll solve for x. All right, so check this out. And the last step, we need to solve for x. Still on step 6, solve for x. So what's next to x? Plus b over 2a, is that correct? So to get rid of the plus, we need to subtract b over 2a. Subtract b over 2a. This cancels. We're left with x equals, check this out, I have negative b over 2a. Then I have plus minus square root b squared minus 4ac over 2a. And, hold on, aren't these 2 fractions? Yes, but do they have a common denominator? Yes. So the common denominator is 2a. And what do we have in the numerator? Minus b plus minus square root b squared minus 4ac over 2a. Copy that, please. And this is my quadratic. We just found the quadratic formula. Copy that, please. So let's see, from the beginning. Let's see how it looks. We start off standard form. Yes. Leading coefficient divided by. Yes. Eliminate the constant. Yes. We subtracted c over a. Add b over 2 squared. Yes. And then I simplified and I did all these 3 steps. This, everybody look up, please. These steps are the steps that we can actually skip and go straight from here, from eliminating, all the way to here, to adding b over 2 squared. Okay, b over 2a squared. From there, we do factor. We factored each part, and we saw that it was a perfect square, so we wrote it like this. And then at the end, square roots, both sides. Then we simplified this side. Then we solved for x. And then we wrote it as 1 fraction. Therefore, we get our quadratic formula. Are we there? Okay, now on your paper, you have a space on the right-hand side. Let's do it again from the beginning. Here we go. So I'm going to move over to this side. Okay? And here we go. Let's start all over. ax squared plus bx plus c equals y. All right? So in order to solve any quadratic, what is our first step? Make y 0. So this becomes ax squared plus bx plus c. Now we can begin. Is it in standard form? Yes. Step 2, we need to divide by the leading coefficient, the LC. So therefore, what's my leading coefficient? A. So divided the entire thing by A, and we're left with A divided by A is 1. 1 times x squared, we're left with x squared. Plus B divided by A is B over A. X plus C over A equals 0. Okay? Step, we already eliminated the, oh no, we haven't eliminated. Next step, eliminate the constant. So what is my constant? C over A. So what is the inverse? Subtract C over A. Subtract C over A. We're left with x squared plus B over AX. We leave a space because that cancels. We bring down the equal sign. And what do we have here? Leave a little space, and then we have minus C over A. Step 4, add B over 2 squared. Pen down really quick. This is where we skip all this, and we go to this part, and we just write plus B over what? 2A squared to each side. B over 2A squared. Copy that, please. And let's continue. So that was step 4. 2A. Hold on. Let me fix this really quick. 2A. Okay? Next step. Step number 5. What do? Factor. So therefore we do square root of the first, which is x, square root of the last. What do we have left? B over 2A. What's the sign of the middle coefficient? Plus, this is squared, equals. And then I bring this down. What is B squared? It's B squared minus 4A squared. And I bring down the negative C over A. At that point, before I do the next step, can we subtract these two fractions? Yeah. We need a common. What do I need to multiply this side by? 4. Times 4A times 4A. So my common denominator is 4A squared. And what's in my numerator? B squared. What else? Minus 4. 4AC. Bring down the rest, the equal, and then we got parentheses, x plus b over 2a squared. And now we arrive to one of our last steps. We take the square root. Square root of this, square root of that. This cancels this, and we're left with x plus b over 2a equals. Can we take the square root of the numerator? No, it stays as plus minus square root b squared minus 4ac. And what's left in the denominator? 2a. Why 2a? Because we are able to get the square root of 4 and square root of a squared. Is that correct? Okay. And our last step, we need to solve for x. So what do I do to solve for x? Subtract b over 2a from each side. Subtract b over 2a from each side. We're left with x equals minus b over 2a plus minus square root b squared minus 4ac over 2a. Do we have a common denominator? 2a. So therefore this is 2a, and we have minus b plus minus square root b squared minus 4ac over 2a. Does everybody see how we shrunk it a little bit? Because we skipped the spots that we actually explained some of them. But now that you know, now you can actually go a little bit faster. Is that correct? Okay, turn your paper over. Let's do it again. Yes. Yes. Here we go. Turn it over. Let's do it again. Start from the beginning. Yeah, the same palm. Let's go a little bit faster. We're going to start with ax squared plus bx plus c equals y. See if you can go and do the next step and the next step and the next step. When you get stuck, look over to the back of your paper, get some help, continue, try and see if you can do it by yourself, and then go back and get some help. Okay, go. All right, so your homework for the weekend. Homework, have fun, and get some rest. Have a good one, guys. Enjoy your weekend. I'll see you guys on Monday. The video will be up on the web if you need to visit it again. Have a good one, guys.